Hello and welcome back. So today we will do a short video. This is regarding how to measure your model, your classification model. So the accuracy of a classification model or the goodness of a classification model depends on the metrics that you choose to measure this model, because you will improve your model based on these metrics. So this helps you to understand whether your model is a good one or bad one. These metrics will give the measure, some form of measure, and based on that you will rerun tests, change your parameters, and re-execute your iterations, and will check. So this is one of the most important things that you will need. However, this video will be short. The concept is quite simple. So let us say this is again our data, and these are the actual values of that we want to predict, and the model that we have created has these values, the predicted, in the predicted column. Okay, so what is the, how do we understand that this is good? And say this is the test data and not the actual data based on what we have trained, but we have applied it and we know the actual values, and these are the predicted values. So the simplest measure could be accuracy, that is the number of values that you have predicted same as your actual data divided by the total number of values. And if you see, so this is an incorrect one and this is an incorrect one. Again, this is correct, this is correct, this is actual 0 and predicted 0, actual 0 and predicted 0. Here it's actual 0 and predicted 1. Okay, so this is 1 correct, 2 correct, then this is 3 correct. So in that way, if you see, if you count, you will see you have 14 correct, and there are total 24 data. So you have 14 out of 24 correct. So your accuracy is around 58%. That is this percentage, 14 by 24 multiplied by 100. Okay, so is that a good accuracy? I think not, because a coin toss accuracy is also 50%. That is a wild guess of whether it's a heads or tail. So it's just a little higher than the coin toss accuracy, right? So we can say this model is not good. Okay, and based on that you can change certain factors, maybe change your learning rate, maybe change your data, maybe improve your data, collect more data and rerun your test, and you try to improve this accuracy. But it turns out that accuracy is not a very good measure for your model performance, because as I already said, coin toss 50%, that says this is a bad accuracy. But accuracy is not a very good measure. Say let's take this example. Say it's a certain case, maybe a prediction whether based on some medical tests where the cases of occurrence are very less and cases of negative occurrences are very high. So by default you predict all zeros in that model, so that will automatically give you something. Say here we have 20 occurrences of negatives and 4 occurrences of positives. So if you just predict all zeros and don't do a coin toss prediction, just predict all zeros, that will give you high accuracy, that is 20 out of 24, right? That is 5 out of 6. But that doesn't mean that your model is very good. So then say your model, you built a model, but how do you measure that? I'll come to that. So let's say you have built a model and it mostly predicts a 0. Okay, and only these 3 are mismatch. But however, you want to give this mismatch higher weightage, right? Because there are less occurrences, and in that less occurrences this has occurred. So probably this sort of measures you want to penalize this mismatch rather than this mismatch. Okay, or maybe if it's easy predicting 0, whether if you had predicted zeros, you might want to penalize also this one. Okay, so accuracy turns out to be not a good, because if this kind of model, it gives you a high accuracy of around 79%, which is close to 80%, but still this may be not desirable. Okay, so let's see. So let's first understand what is a confusion matrix. Okay, so let's look at this chart. So along the columns you have the predicted values, and along the rows you have the actual values. Okay, and this cell is, that is predicted 1 and actual 1. Okay, so that's only 1 in this case, so 1, you put the count there. and in this cell you put you have its actual one, but it's predicted 0. Okay, so this 3. Okay, so yeah, so actually we want to penalize this, right? That this should not be the case. Accuracy cannot penalize this. Okay, so this is very important, and we want to reduce our errors in this portion. So we want to improve our model so that our errors are reduced in this portion. And what measure we are going to find out? So for that we are trying to understand the confusion matrix. So this is actual 1 and predicted 1, and we call that true positive, and this is false negative, that is we have predicted 0 but it's actually 1. Similarly, it's actually 0 and you have predicted 1, so it's called false positive. There are 2 occurrences, and this is all that you have actual negatives and you have also predicted. So that's a large number, 18. Okay, so we call these things true positives, false negatives, and true negatives. So we introduce 2 matrices for measurement. One is precision, which is true positive by true positive plus false positive. And see, if you calculate true positive by true positive plus false positive, it's 1/3. 1 by 1 plus 2, 0.33. Okay, it's not a very good number. And recall, which is true positive by true positive plus false negative, which is 0.25. Okay, so in terms of document retrieval, which we will come later on, let's suppose you are trying to retrieve relevant documents from a group of documents by using some models. Precision is defined by the number of relevant by total number of retrieved. Okay, and recall is defined by number of relevant by total number of relevant. Okay, so this we will visit when we start exploring text analytics, this definition of precision and recall, but that will also bring us to this formula. Okay, so is there a way? So we might want to take a recall or a precision as our measure based on what we want to penalize. Okay, so is there something where we can combine, whether we can combine these two? Yes, there's a measure called F score or F measure, which is 2 into precision in 2 times precision multiplied by recall by precision plus recall, and you say it's 0.28, so which is much lower, and so it shows us that our model is not effective. Okay, and now we have to improve this 0.21 and bring it closer to 1. So that is better measurement or better metrics to measure our model, and we might change several factors to improve our model, like the learning rate, data, or maybe regularization based on the type of problem. And we can compare training data and test data and find out whether it's a bias or a variance. Okay, so in this regard, there's one more thing that you can configure in a classification scenario, that is the threshold. Okay, so mostly our models give some sort of, does not give a 0 or 1, we round it to 0 or 1. It gives a probability of how much it may be 1 or 0, and we round that probability to 1 or 0, right? So usually you take the midpoint for your probability, and anything greater than 0.5 is 1 and less than 0.5 is 0. This we discussed in one of our hands-on classes. So maybe if you change the probability, to be lower, like 0.3, maybe you would have detected these things. Maybe these probabilities are actually 0.4, 0.46, 0.45, and maybe 0.32. Okay, and these are also probabilities something higher, okay, some lower than that, which is 0. So based on that, you can inspect the probability values and change your threshold. Maybe something greater than 0.3 you can term as 1, and less than 0.3 you can term as 0. So that might improve your metrics of F score. So threshold is something also, another hyperparameter, the parameters that you can tune to improve your model. The weights are the parameters actually which you learn, and these are called hyperparameters. So you can train this and change your threshold and test and see which improves your accuracy. Okay, so that's all about measuring the classification. So I plan to move on to other classification or other algorithms and do a proper hands-on on an use case of classification, which will help us to understand Python also better. Thank you.